Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello everyone, I'm John, a math teacher. This time, I'll be working with senior 6 students. We are going to continue our unit 4 of integration, right? Integration. And we are going to continue the integration by change of the variable. This is the part 2, because already we know how to integrate those kind of integral involving the method of change of the variable. But of course, we can't start without passing it through exercise to see whether you still understand, you still remember how to apply that method. So there you have the activity. Evaluate the following integrals by change of the variable. We have these 3 examples, right? So number 1, you are going to integrate 2x plus 3 divided by x squared plus 3x minus 5 dx. That is number 1. Number 2, integral of e power 2x over 1 plus e power x dx. And the 3, the integral of x dx divided by square root of 1 minus x power 4. Yes. So you have 1 minute to find those integrals. Of course, use the method of integration by change of the variable. Have you finished? Not yet. You need some few seconds to finish. Then we make the correction on chalkboard. Are you done? Oh, thank you very much. Now, let us evaluate our integrals on chalkboard. Thereafter, we shall see whether those answers are the same. Solution. Number 1, integral of 2x plus 3 over x squared plus 3x minus 5 dx. Okay? I'm going to make the relationship between this denominator and numerator. So the problem is not 2x plus 3, but x squared plus 3x minus 5. So I can let x squared plus 3x minus 5 equals z. Differentiating both sides, I'll be having 2x plus 3 dx, which is equal to dz. Already, my numerator is equal to dz. So I'll be having integral of 2x plus 3 dx, means I can write 2x plus 3 dx divided by x squared plus 3x minus 5, which is equal to integral of all of this dz divided by z. And this is the standard integral, means that you have ln of z plus c. So replacing z by its value, the integral is ln of x squared plus 3x minus 5, n plus c. I'm done with this first example or activity. Number 2, integral of e power 2x divided by 1 plus e power x dx. Pay attention. We have e power 2x and e power x. We can make a relationship between them so that the method of integration by change the variable becomes very, very easy. So this can be written like integral of e power x times e power x dx divided by 1 plus e power x. There is no change because e power x times e power x, it is e power x plus x, then x plus x, it is 2 power x. So there is no change. Then we let 1 plus e power x equals z. What's that? Differentiating both sides. Of course, the left-hand side, the variable is x. The right-hand side, the variable is z. I'll be having the derivative of 1, that's 0. The derivative of e power x, it is e power x. Then dx, which is equal to dz. But still, I have e power x. I can express e power x in terms of z. Means that from 1 plus e power x equals z, I can deduce the value of e power x, which is equal to z minus 1. Are we together? Okay. Now, I'll be having integral of e power x, which is equal to z minus 1. Then e power x dx equals dz. It is this one. So dz divided by z. Are we together? Very nice. Now, you know when you have a plus b divided by c, it's no different to take a divided by c plus b divided by c. It's the same. So I'll be having integral of z divided by z minus 1 divided by z dz. This is integral of 1 minus 1 divided by z dz. Then this is equal to integral of 1 dz minus integral of 1 over z dz. And I'll be having z minus, this is standard integral or immediate, that will be ln of z plus c. So replacing z by its value, I'll be having 1 plus e power x minus ln of 1 plus e power x plus c. Would you like to know why I use parentheses instead of absolute value sign? So it is known that e power x is always positive, right? When it is positive, a positive number plus 1 is also positive. Still, the expression will be positive. So knowing that my expression is always a positive, I'm free to use parentheses instead of absolute value sign, right? And I'm done for this number 2. The last integral of x dx over square root of 1 minus x power 4. I have to make a relationship between these x power 4 and x. But when I have, this can be written like integral of x dx over square root of 1 minus x power 2 squared. And you know that when you have such an integral, when you have 1 divided by square root of 1 minus something power 2, already the answer should be involved sine inverse of something, isn't it? And that is immediate or standard integral. So here I can, because I have to use the method of integration by change of variable, I can let x squared equals m, right? Then differentiating both sides, I'll be having 2x dx, which is equal to dm. Then x dx is equal to dm divided by 2. Already x dx is equal to dm divided by 2. Then my integral becomes x dx over square root of 1 minus x squared. Result power 2 is equal to integral of dm over 2 square root of 1 minus m squared. That is a half integral of dm divided by square root of 1 minus m squared. This is standard one. It means that you have a half sine inverse of m plus c. Then you replace m by its value. The answer is a half sine inverse or arcsine of x squared, then plus c, and I'm done. You can check with those answers. I hope they are the same. And now you understand how the method of integration by change of variable works, but you have to be clever because you try your best to find one of the standard integrals. So this time we're going to continue with the same method of integration by change of variable, but with small change, of course, different from what we did before. So we have integral of this form. Integral of the form f derivative f of x dx. Are we together? Are we together? Okay, very nice. Let me take the same example. Integral of 2x plus 3 divided by x squared plus 3x minus 5 dx. Of course, it is solved here. The answer is here. Are we together? This is the answer when you use the integration by change of the variable, isn't it? But when you observe 2x plus 3 is the derivative of x squared plus 3x minus 5. Isn't it? Already the numerator is the derivative of the denominator. Means that I can write this integral as integral of derivative of x squared plus 3x minus 5 divided by x squared plus 3x minus 5. Of course, dx. Is this clear? Okay, thank you. So, as the numerator is the derivative of the denominator, and you have seen that this is ln of the denominator we have there, it means that when the numerator is the derivative of the denominator, the answer is ln of x squared plus 3x minus 5 plus c. And you observe this function, it means that you have ln of f of x, then plus c. Isn't it? It means when you have the integral of f dash of x divided by f of x dx, this is equal to ln of f of x plus c. Please write this formula in your record book for reference. I give you a minute to write this, yes, and I give you another example, which is there on chalkboard. Okay, hurry up. This is example number 1. 2 integral of sec squared x divided by tan x dx. Integral of sec squared x divided by tan x dx. Okay, hope you are done. Follow on chalkboard. If you change the variable, of course, you will be having tan x equals t, for instance, and differentiating both sides, you will get sec squared x dx, which is equal to dt. And from here, you have a sec squared x dx. Means that sec squared of x is the derivative of tangent of x, isn't it? It means that I can write the integral derivative of tan x divided by tan x dx. Already as the numerator is the derivative of denominator, the answer is trivial, that is ln of tan x plus c, and I'm done. Very simple, right? Do you need another example? No, I don't. It is not very necessary because already the method is very simple, it's understandable. Let us have another kind of integral involving the function and its derivative. For this, it was a ratio, but now I'm going to use the product of a function and its derivative. B, integral of the form fx power n times f dash of x dx. For example, I can take that one integral of x squared plus 3x minus 5 times 2x plus 3 dx. Then, by change of variable, I can let x squared plus 3x minus 5 equals t. Differentiating both sides, I get 2x plus 3 with respect to the variable x, which is equal to dt. When you observe 2x plus 3 dx is this one. Is that clear? Is it clear? Oh, very nice. Okay. Now, go back to my integral. I'll be having integral x squared plus 3x minus 5 is equal to t. All of this is dt, isn't it? And I get, this is a standard one. I get t, because the exponent is 1. That will be t power 1 plus 1. That is t squared divided by 2. Then plus c. And replacing t by its value, you get a half x squared plus 3x minus 5 raised to power 2, then plus c. You can make a relationship between this one and this. So it means that integral of x squared plus 3x minus 5, x squared plus 3x minus 5, as this is the derivative of this function, I can multiply by d for dx of this function, x squared plus 3x minus 5 dx, which is equal to a half times x squared plus 3x minus 5 raised to power 2, then plus c. I hope it is very simple. But if you observe, I can have f of x is like f of x power 1, right? Times the derivative of my function dx, and you get, this is x squared, that is f of x, because it is 2, that is n plus 1, divided by n plus 1, then plus c. Let me give that formula somewhere so that you can forget. Means the integral of f of x power n times its derivative dx, this is equal to f of x power n plus 1 divided by n plus 1. Of course, you have to add that constant of integration plus c. Obviously, n must be different from -1. Please copy this formula in your record book for reference. It can be taken as a standard integral, right? Okay. You have that activity. We have 4 integrals. Please choose 2 among those one, then evaluate them. You just choose 2 where you can apply both formulas for the ratio of a function and its derivative and the product of a function and its derivative. You choose 2. I give you 1 minute. Because you applied the formula, I hope you are done. Isn't it? Not yet? Oh, sorry. So you need a few seconds now. Okay. Thank you. Let us take which one? Number 1 is no different from what we did. It is already done, I think. Yeah? Let us take number 3 and 4. Okay. 3 integral of tan inverse of x squared 1 plus x squared dx. This can be written like integral of tan inverse of x squared times 1, or dx, divided by 1 plus x squared, isn't it? If you observe 1 divided by 1 plus x squared is the derivative of tan inverse of x. Means that we have a dirty formula, but n is equal to 2, isn't it? So the answer is, it is like integral of tan inverse of x squared times the derivative of tan inverse of x dx, which is equal to tan inverse of x power n plus 1, this is a 3, divided by 3 plus c, and I'm done. Right? And 4 integral of minus 4 tan x dx, this can be written like minus 4 integral of tan x dx, which is minus 4 integral of sin x over cos x dx. Already, we know that the derivative of cos x is minus sin x. Means that I have neg 4 integral of minus d of dx cos x divided by cos x dx, which is equal to 4 ln of cos x plus c. Negative sign is there, and I'm done. So you have a homework. This application, you have those integrals from 1 to 8. It's just the application of what you did for those two formulas. It's up to you to see whether you can make a small arrangement so that you get one of those formulas, then you apply them to give immediately the answer. Thank you very much. Thank you for your attention. I hope to meet you next time. Have a nice day.